Today we're going to look at finding area under a curve, and this is going to eventually bring us to integrals. What we want to do is find the area under a curve, and our equation is negative x squared plus 5. If we were to draw a little sketch of that, we know it's an upside down parabola, and it's up 5. And again, it's an upside down parabola, looks something like this. Now we only want the area under the curve from when x is 0 to x is 2. What we want to do is divide the interval from 0 to 2 into however many parts you want. Let's try 4 equal parts. So if I divide it up, it'll look like that. We want to draw rectangles from these points to the graph of the function. Make sure your rectangles are under the curve. Okay? So I'm going to start at this first marking, 0.5. I'm going to go up until I touch the curve and then go back. And I made a rectangle. Then go to 1. Go up, touch the curve, and then go back and make a rectangle. 1.5, go up, touch the curve, and go back. And then 2, go up and touch the curve and go back. So I've made 4 rectangles underneath the curve. What are the endpoints of these rectangles? Again, look at the right side. So we had an endpoint of 0.5, we had an endpoint of 1, 1.5, and 2. Since we divided this graph into 4 parts and it was only 2 units wide, what's the width of each little rectangle? So we had from 0 to 2, right, cut up into 4 parts. So that's 2 units cut into 4 parts, which is a half each. So the width is a half of each. So if the width is a half, to find the area of this rectangle, we just now need to know the height. The height touches the curve right here at 0.5. So if I plug 0.5 into the function given, I can figure out that height. So the first rectangle's height will be the function value at 0.5. The second rectangle will be the function value at 1. The third one will be at 1.5. And the fourth one when the function value is at 2. If I were to plug 2 in, 2 squared is 4, negative 4 plus 5 is 1. So you can see this point would be 2, 1. So the width of this little rectangle in the end is 0.5 and the height is 1. So you can find the area of that little rectangle, and that's what we're going to do here. So to find the area of the region under the rectangle, as close as we can, is add up those 4 rectangles. The first rectangle had a width of a half, and the height was the function value at 0.5. So a half and the function value, if you plug 0.5 into the equation, negative 0.5 squared plus 5 will give us 4.75. Now the second rectangle had a width again at 1/2, and the function value of 1 was the height, or in other words, a half times 4. The third rectangle, you're going to follow that same pattern. The function value at 1.5 is 2.75, and the fourth rectangle, the function value at 2, we already said was 1. So now we're going to multiply a half times all these and add up our area. So adding up each of these areas, we get an area of 6.25. And what we did to figure out this area, we used what's called the Rram. That stands for the right rectangular approximation method. We use the right endpoints to make rectangles to approximate the area under the curve. Let's go on to the next. We're looking at the same exact problem, but this time we're going to use the left endpoints. Or in other words, we're going to approximate doing Lram, the left side. Left rectangular approximation method. Same function, 2, 3, 4, 5, upside down parabola from 0 to 2. We're going to divide this up into 4 equal parts. This time let's make our triangles, again 4 equal parts, using the left endpoints. And the triangles this time are going to actually fall above the curve. So if I start at 0 and go up to the curve and across a width of a half and then come down, there's my first rectangle. Then at 0.5 I'm going to go up to the curve, across a half, and down. Then at 1, I'm going to go up to the curve, across the half and down, and continue. Notice my rectangles are sitting above the curve. The end points of the rectangles are 0, 0.5, 1, 1.5. Notice I included 0 in this one and not the 2. Like on the right side, we included the 2 and not the 0. The width of every rectangle is still a half because it was 2 whole units cut into 4 pieces. Now the height. The first height is the same as the function value at 0. So plug 0 in, you actually get 0.5. So the height of the first rectangle is 5. The height of the second rectangle is when we plug in 0.5. The height of the third rectangle is when you plug in 1. And the fourth rectangle is when we plug in 1.5. And we actually already did these computations on the front. So let's now find our total area. The first rectangle has a width of a half and the height at function of 0, which was 5 units. The second rectangle was a width of a half and the height was the function value at 1/2, which we had from the front of the worksheet, which was 4.75. Then the third rectangle, the width is a half, and the height was function value at 1. When we plug that in, we get 4. And the last rectangle, the width is a half, plug in 1.5, you get a height of 2.75. So complete this computation and get an area, this time, of 8.25 units. So when we did the left rectangle approximation method, we got an area of 8.25. Remember, those rectangles sat above the curve. When we did the right rectangle approximation method, we got 6.25, and those rectangles sat below the curve. So we can assume that the correct or the exact area is somewhere in the middle.